So welcome to the another video in the series of lectures of Jee Advanced Compendium of Definite Integrals. This is another beautiful question that was being asked in Jee Advanced. This is really a good question, so let's solve it. We can see that there is a function fn that is defined, fnx, that is defined as summation r equals to 1 to n, and in numerator we can see that sin square x upon these things, and Gn is defined as product of continuous fr, where r is 1 to n, for all n belongs to 1, 2 and 3. So if in is, then an integral in is defined from 0 to then in is given as lower limit 0 to upper limit pi fnx upon gnx. So that's the question. So let's analyze this. First we have to solve this. After solving this, then we will reach here to find Gn, and then only we can solve this problem. So we can see, we know one formula, that if cos square a minus cos square b actually equals to sin a plus b into sin b minus a. Okay, so that's a formula that is omniscient to all of us. So we'll use this formula in the denominator to solve that, to simplify that first of all. Okay, so let's do that. So here, while doing that, we can write this as fnx as, I think, yes, it is visible, so let me write it from here. So we are going to solve it, and fnx is actually equals to summation sin square x upon, we'll use that formula, so it will be sine of r plus 1x into sine of rx. Okay, that's the formula which we can use. To simplify it further, what I'm going to do is I'm going to take one sine out, okay, one sin x out, and this sin x I can also write as sine of r plus 1 minus 1 into x. Okay, and in denominator we have sine of r plus 1 x into sine of rx. Okay, now we'll open the numerator, and when we'll open this, we can see that it will be, I am running out of space, but nevertheless let's do it. So I'm opening it here, so this will be sin x, and this summation would be, I'm opening it, so this would be sin a, so sine of r plus 1x, okay, into cos b, okay, cos is, sorry, this is actually r, I'm so sorry, this is actually r. Okay, only then r and r will be cancelled, so this will be cos rx, okay, minus cos r plus 1 x into sin rx, and in denominator we have sin r plus 1x into sin rx. Here also in denominator we have this thing, sin r plus 1x and sin rx. Okay, so that's it. Now we can see that here sin r plus 1x is getting cancelled, here here sin rx is getting cancelled, so what we are left with is sin x, and in summation we are left with the cot of rx, okay, minus summation cot of r plus 1x. Okay, this whole thing is now f of fnx, so we can simplify it. So how we can do this also? So we'll just put it value. So this is from r equals to 1 to n. So this is from r equals to 1 to n, and this is also from r equals to 1 to n, okay, as written in the problem there. So what this becomes? This becomes cot x plus cot 2x all the way up to plus cot nx, and this is minus times cot 2x minus cot 3x all the way up to minus cot n plus 1 into x, okay. So let me write it more clear here. This is dot minus cot n plus 1 into x, okay. So everything will be cancelled here, this whole thing will be cancelled. Only what will left is cot x minus cot n plus 1 into x, and if we'll break this in cos x upon sin x, cos x upon sin x minus cos n plus 1x upon sin n plus 1x. So, and if we cross multiply it by taking LCM, it will become sin n plus 1 minus 1 into x, okay, and in it will simplify as sin a minus b, and a will be n minus 1 and b would be 1, and in denominator we will left with sin x into sin n plus 1 into x. In numerator we can see that it will be sin nx, okay. Let me think once. Yes, it will be sin nx upon sin x into sin n plus 1x, okay. So this is, and let me tell you, we are missing an extra sin x here. So this whole thing will multiply with sin x, because this is getting multiplied with sin x, as we can see here. So we will multiply it by sin x. So this will also get multiplied with by sin x. So this will also get multiplied by sin x. So we can see that sin x and sin x is cancelling here too. So fnx comes out to be sin nx upon sin of n plus 1, okay, into x. So this is fnx, okay, this is fnx. So I'll ask you to, I'll request you actually to memorize this, because it is taking all the space and we have to even find g and x and then we have to solve it. So I'm gonna rub the board and I'm gonna use this directly to solve it, okay. So now we simplified fnx as this. Now we'll find gnx. So we can see that gnx is continuous multiplication of, this is r equals to, this is n equals to 1 to n, sorry, n equals to 1 to n, and this is fnx, okay. So we can simply put the values of 1 and so this would be, gnx would be sin x, we'll put 1, so this will be sin x, and in denominator we will got sin 2x. Here will be put 2, so sin 2x, and this will be sin 3x, here sin 3x, and this will be sin 4x, all the way up to, we'll left with sin nx, and in denominator sin n plus 1 into x, okay, and this whole thing will be cancelled, and gnx would be sin x upon sin n plus 1 into x, okay. So we simplified fx and we simplified gnx. So again we can write here gnx equals to sin x upon sin of n plus 1 into x, okay. So because I need more space, so I'm gonna rub this. Okay, so I'm so sorry, but I have to because I'm running out of space. So now we have fx, and now we have fnx, and we have gnx. Now we can solve this. Okay, so let's solve it. So the question says that in is defined as 0 to pi fnx upon gnx. Okay, that's how the in is defined. So fnx is what? Let's solve it. So this is from 0 to pi. Fnx is sine nx upon sine n plus 1x. Okay, into gnx is sine n plus 1x upon sine x. Okay, so these things are cancelled here, and this becomes from 0 to pi sine nx upon sine x into dx. Okay, so this is dx here. I mean, that is obvious, don't need to write it. So this is in. Okay, this is in, and so we have to find from 1 to 100. So in from 1 to 100. So let's find I1. Okay, I'm gonna find I1 here. So let's find I1. I1 is 0 to pi. We'll put here 1, so this will become sine x, and in denominator we have sine x. Okay, dx, so this becomes pi. So I1 comes out to be pi because sine will be cancelled, and after putting limit we'll get pi. Let's calculate I2. Okay, so this is I1. Let's calculate I2. So in I2 we'll go from 0 to pi, and this will be sine 2x upon sine x, and we can expand 2x as 2 sine x into cos x. So this will be 2 integral of 0 to pi cos x, and integral of cos x is sine x, and from limit you can see it will be 0. Okay, so I2 equals to 0. Thus we can see that if here n will be even, we can say that it will be always 0, because ultimately it will get simplified, and there will be a term cos x that will be which integral will give us 0. So we can say that I2 equals to 0 equals to I4 equals to I6 all the way up to equals to I100. So all even for every even n, this thing will become 0. Now we have got in. So let me first kind of find in for you. So this is in. Now let me find in minus 2 for you. Okay, now let me find just in minus 2 for you, what we are getting. So let me find it here. So in minus 2 is 0 to pi sine n minus 2 into x upon sine x. Okay, this is in minus 2. Now what I'm doing is I'm just subtracting in minus 2 and in. Okay, so just to get an idea that what we are getting. So in minus 2, that's what I'm finding here. So this will become 0 to pi and sine nx minus sine n minus 2 into x, and in denominator we'll have sine x. Okay, we'll use sine c minus sine d formula here in numerator, and what we'll get is we'll get 2 cos nx minus nx. So I think this will be n minus 1 into x. So I think it would be 2 cos n minus 1. Okay, into x, because 2 will be cancelled, and sine nx will be cancelled, and we will have x. Okay, we'll have that in numerator, and we have sine x in denominator. We'll integrate it from 0 to pi. Okay, this is in minus 2. Okay, and we can see that sine x is getting cancelled here, and integral of cos with anything, integral of cos will give us sine, and sine will limit 0 to pi, will give us 0. So we can see that in we can see that I and this will be 0. So we can see that in and this relation holds between in and in minus 2, and that equals to 0, and this implies that in equals to in minus 2. Okay, that's a rule here. So using this we can also verify this also. Okay, so from this what we can do is, so if we'll put n equals to 3, what you will get? I3 equals to I1. If we'll put I equals to 5, we'll get I5 equals to I3 equals to I1. If we'll put I equals to 7, so we can, using this rule, we can write that I1 equals to I3 equals to I5 equals to I99. Okay, and these are, we can see 50 terms. So this equals to pi, this equals to pi, this also equals to pi, and all the way to this also equals to pi, because effectively these everything is equals to 1. So how many terms are there? There are 50 terms, so this becomes 50 pi. Okay, so summation of, therefore summation of, we can see from k equals to 1 to 100, in equals to 50 pi, and this is given to us as k pi. So pi cancels and k equals to 50. I think that's the result we have. So that's the result we have. Okay, so we can see the answer is 50. So option number A is correct. Now you may ask that why we didn't consider I4 and all thing, because we can see that I4, I6, all even n give us 0. Okay, so that's a very beautiful problem that Jee Advanced asked, and that's all for today. So like, share and subscribe. Thank you.